Imagine stepping out your door into a city that hums with an almost unseen intelligence. Traffic flows not because of fixed lights, but because the entire street network, well, it sort of breathes and adjusts in real time, anticipating congestion before it even forms.
Yeah,
Energy grids silently balance demand, drawing from a tapestry of renewable sources, while the very air you breathe is continuously sampled, analyzed, and optimized for health and comfort.
right.
This isn't just the stuff of futuristic movies anymore. It's the burgeoning reality and ambitious vision of what we call the smart city.
Hmm.
We're talking about an urban environment designed to monitor its own pulse, anticipating nearly every need through an intricate, pervasive web of technology and data.
Exactly. And this isn't about, just slapping a few screens on a bus stop. It's
Right.
way more fundamental. It's about urban environments that transform by leveraging a vast ecosystem of sensors.
An ecosystem is censored.
Yeah, and these sensors aren't just passively observing. They're actively collecting just torrents of information from every corner of urban space, then using that data to manage city assets and deliver services with incredible, almost fluid efficiency.
Okay.
Thinkers like Carlo Ratti at MIT's Sensible City Lab have been really at the forefront of outlining this ideal. Cities that aren't just bigger, but genuinely more responsive, more sustainable, and ultimately more livable for every one of their citizens.
When you paint that picture, it sounds almost utopian, doesn't it? A city that truly works for everyone, thanks to constant feedback loops and, well, intelligence systems.
It does sound appealing, yeah.
But as we embark on this deep dive into the smart city, we also have to immediately confront the powerful counter-narrative, or the significant challenges and profound ethical questions that inevitably arise when technology permeates every aspect of urban life.
Absolutely crucial.
We're talking about the specter of mass surveillance, the complexities of data privacy that touch our deepest personal freedoms, and the very real risk of creating cities that are incredibly efficient, yes, but also potentially sterile, overly controlled, or even inequitable.
It's a truly critical balance we need to strike. Our mission today is to unpack these sources, to explore both the transformative potential and the critical dilemmas with equal measure.
Right.
We need to understand with clear eyes whether we are genuinely building better cities, places that enrich human experience, foster community, and amplify individual agency, or if we're simply building more technologically advanced ones, prioritizing data and automation above all else.
What does smart truly mean?
Exactly. What does smart truly mean when we apply it to a city, to a shared human habitat? That's the core question we want to explore with you today.
Okay, let's unpack this fascinating and complex topic. To really grapple with the smart city, we first need a rock-solid understanding of what it is today. When we talk about a smart city, what are we actually referring to? It's clearly far more than just, connected devices.
Oh, far, far from it.
Mhm.
At its heart, a smart city is an urban environment that has developed a kind of high-tech nervous system.
A nervous system.
Yeah, it's not just passively sitting there. It's got an ecosystem of sensors, its eyes and ears, if you like, constantly soaking up data from every street corner, every building, every vehicle.
Okay.
It's not just observing, it's actively perceiving and reacting to its own pulse. From traffic patterns to air quality, from waste levels to public safety incidents, this constant intake of data is really the foundational layer.
So if the sensors are the eyes and ears, how does that information then get used? What's the mechanism that elevates it beyond just being a giant data collector to being genuinely smart and actionable, transforming the urban experience?
That's where the magic, or perhaps the engineering, truly happens. The sources describe how network-enabled actuators can subsequently transform that space.
Actuators.
Okay? Think of it this way. The city isn't just observing, it's constantly running experiments on itself. These data-driven feedback loops mean sensors gather information, say, about traffic congestion,
Right.
and then network-enabled actuators, like smart traffic lights or variable message signs, immediately adjust to improve flow.
Mhm.
The city becomes a living lab, always tweaking, always optimizing like a giant, self-improving organism.
Wow.
That's the essence of turning the city into a reflexive testbed and workshop for connected habitation, all built on a common platform of ubiquitous computing, where computing power and connectivity are literally everywhere, seamlessly woven into the urban fabric.
That's truly fascinating. So the city isn't just a collection of buildings and streets. It becomes a giant, interconnected computer, constantly learning and adapting. And this has opened up entirely new fields of study and practice, right? What kind of frontiers are emerging in this space?
Absolutely, it's a rapidly expanding frontier. Within the field of smart cities, we're seeing a plethora of approaches emerge, pushing the boundaries of what's possible. These range from civic hacking.
Civic hacking, what's that?
Well, it's where citizens might use open source data the city makes available, to map things like, say, food deserts in their neighborhood, or identify inefficient bus routes based on real-time passenger data.
Okay.
And then they propose their own solutions directly to city planners. It's about empowering citizens with the very data that runs the city.
Interesting.
Then you have data management strategies, which are crucial for handling the sheer volume, velocity, and variety of information flowing in, ensuring it's secure, accessible, and meaningful.
Makes sense.
We also see programmable architecture. Imagine buildings whose facades automatically adjust to sunlight, or whose internal spaces reconfigure based on occupancy, maybe shifting from a public co-working space during the day to a private event venue at night.
Wow, buildings that change shape.
Sort of, yeah. And this leads to the really audacious concept of autonomous sentient space, where parts of the city literally self-regulate, like a park that adjusts its lighting based on pedestrian traffic, or even detects localized air quality issues and triggers purification systems.
This sounds almost biological, a true integration of technology and the human environment. It reminds me of the idea of the cyborg city that some thinkers have discussed, where technology isn't just external but deeply intertwined with us.
It's a powerful metaphor, and it's directly referenced in our sources. We can describe humanity today as a new form of Homo sapiens, one with an entirely new apparatus, where our tools are no longer separate objects we merely wield, but increasingly seen as dynamic extensions of our bodies and minds.
Like our phones.
Exactly like our phones. This isn't just about a hammer or a simple lever. It's about constant two-way cybernetic exchange. Your smartphone. It's an extension of your memory, your navigation, your social network. We are constantly feeding it data, and it's constantly feeding us information back, shaping our decisions and perceptions.
So we're not just using technology, we're merging with it in a fundamental, almost symbiotic way. Our digital devices are like external organs.
Precisely. This concept really took hold with cyborg theory, which emerged back in the 1980s, particularly with Donna Haraway's seminal work. It posited this new paradigm of human social, biological, technological existence, arguing that humans are no longer pure biological entities, but these post-Second World War hybrid entities intertwined with information systems and ergonomically controlled laboring, desiring, and reproducing systems. It's about recognizing the profound and often invisible ways technology has become part of our identity and our interaction with the world. Paul Virilio, a French theorist, even called this a revolution of transplants, describing how digital technologies have become these dynamic extensions of our bodies and minds, demanding that constant and two-way cybernetic exchange. By extension, as we embed more and more of this technology into our shared spaces, making them responsive and intelligent, our cities themselves inevitably become cybernetic as well. They become an extension of our collective technological being.
That's a profound shift, moving from just using a tool to having the tool become an integral, constantly interacting part of our very being, and then projecting that onto the urban landscape itself. It makes you wonder if this kind of massive urban transformation has historical parallels. It can't be entirely new, this idea of fundamentally redesigning cities with new technologies and grand visions.
You're absolutely right. This isn't entirely novel.
Yeah.
If we look back through history, we find striking precedents for such sweeping, technology-driven urban redesign. Consider Georges Eugene Haussmann's monumental 19th century transformation of Paris.
Ah, yes, Haussmann.
His goal wasn't merely aesthetic, though the wide boulevards are certainly beautiful. It was to provide a splendid framework for the great traditions, while simultaneously making Paris the first great city of the industrial age.
Right.
He literally tore down medieval slums, replaced narrow winding streets with grand tree-lined avenues designed for rapid troop movement and the flow of commerce, and integrated new infrastructure like sewers and gas lighting.
How huge undertaking.
Massive. This was a massive technology-driven urban redesign, albeit with gaslight and wide boulevards rather than sensors and data. It was about creating a city that functioned efficiently for the era's dominant technologies and social demands.
So just like today, they were fundamentally altering the city's structure to adapt to the dominant technology and economic demands of the era, and perhaps even to exert a certain level of social control. What about even earlier forms of urban planning?
Even earlier, medieval urban planning shows this drive for efficiency and purpose. We see the development of planned towns or bastides across Europe. The process involved a founder or bastidor, almost like an urban startup CEO back then, who would meticulously lay out the streets and marketplaces, often in a grid pattern. Then each man would build his own house within this predefined grid. The emphasis was often on economic return, establishing new centers for trade and agriculture, and interestingly, fortifications or walls were frequently absent because they were simply too costly.
Right, practicality ruled.
Exactly. This demonstrates early forms of planned urban growth focused on order and efficiency, even if simpler in its technological expression compared to Haussmann's engineering feats.
It's clear that intentional design for efficiency and purpose is a timeless human endeavor, regardless of the era or the available tools. And we can't talk about grand technology and design without mentioning some of the pioneering engineers who truly pushed the boundaries of what was thought possible.
Indeed. Figures like Isambard Kingdom Brunel immediately come to mind. His soaring feats of technological prowess became a new aesthetic at the nexus of architecture and engineering.
Brunel, yes, the bridges, the tunnels.
Exactly. His work exemplifies overcoming incredibly complex challenges with sheer ingenuity and the large-scale application of cutting-edge technology. He wasn't just building, he was redefining what could be built.
Give us an example that really illustrates that ambition and the sheer difficulty of what he was attempting.
Well, take his tunnel construction projects, for instance.
Huh?
His Thames Tunnel, though primarily engineered by his father, Mark Brunel, highlighted the immense difficulties involved: constant water inundation, structural collapses. It was a constant battle against nature.
Right.
Brunel himself famously battled the elements with his box tunnel, which was a marvel of its time, pushing the limits of railway engineering. Or consider the launching of his colossal steamship, the Great Eastern.
The Great Eastern, yes.
This wasn't a simple ship. It was the largest vessel ever built at the time, designed to carry thousands of passengers around the world without refueling. Its launch was an epic feat, requiring no less than 18 hydraulic presses, immense timber cradles, and a massive workforce.
18 hydraulic presses.
Yeah, it took 3 months, demonstrating an immense scale of engineering and almost superhuman persistence. There's a powerful quote that captures this historic engineering mindset, attributed to Brunel: to stick to the one point of attack, and if the force first brought up is not sufficient, to bring 10 times as much.
Wow, that's determination.
It really captures the spirit of relentless problem solving, a profound determination to achieve the vision, a spirit that absolutely resonates with the ambitions of smart city development, where complex integrated systems are built against daunting odds.
That's a truly powerful philosophy, that relentless pursuit of a solution, bringing whatever force is necessary to bear. It shows that the ambition for large-scale, tech-driven change in cities is deeply rooted in our history. Now, with that historical context, let's dive into the actual building blocks of the smart city, the real-world applications that are being implemented right now, and how they're aiming for unprecedented levels of efficiency.
Right. One of the most significant and visible applications is in intelligent mobility. Carlo Ratti and Matthew Claudel highlight ambient mobility as a core smart city concept.
Yeah.
The idea is that silicon, rather than asphalt, is eroding the symbolism of personal automobiles.
Silicon rather than asphalt. I like that.
Yeah, the car is no longer the sole supreme symbol of liberation or empowerment. Its role is changing, becoming just one option in a much broader, smarter system.
So, what replaces it? If the personal car isn't the singular answer anymore, what does this new ambient mobility actually look like for someone living in a smart city?
It's replaced by a broad transportation portfolio based on real-time information platforms. This means you, as a citizen, have a diverse menu of optimized options at your fingertips, perhaps through a single app.
Like a mobility app.
Exactly. We've all seen examples like city bike and city car sharing systems that are now commonplace in many urban centers, allowing residents and visitors to use a vehicle for short periods, often on demand. But it goes further. Your app might suggest a combination of walking, a shared e-scooter, or a public transit line, all dynamically routed based on current traffic, weather, and maybe even your personal preferences.
I've definitely seen those bike share and scooter share programs everywhere, and they've changed how people move. And personal activity trackers play a role here too, don't they? How do they connect to this broader mobility picture?
They absolutely do. Your personal activity trackers, which monitor everything from steps taken to calories burned, contribute to this ecosystem. The ambient mobility portfolio considers external factors like your ecological footprint,
Right.
perhaps suggesting walking or cycling to reduce emissions, and your personal health prioritizing active transport, or maybe a less strenuous route if you're recovering from an injury. It's about optimizing movement, not just for speed or cost, but for sustainability and individual well-being too, leveraging data from your personal life and from every part of the city to offer truly personalized, intelligent options.
Beyond just getting around, how does smart city technology integrate into the very foundational infrastructure that sustains us? I'm thinking about crucial lifelines, like water and power, the things we often take for granted until they fail.
Yeah, smart utilities are not just critical. They are the unseen backbone of a truly intelligent city. A truly smart city would have interconnected dynamic systems for managing every essential utility.
Okay.
That includes water utilities, ensuring efficient distribution and leak detection, sanitary sewage utilities, and storm drainage utilities, which monitor flow and prevent overflows or flooding, especially important with climate change impacts.
Definitely.
Fuel distribution utilities, hydronic and steam energy utilities for heating and cooling networks, and of course electrical utilities, including smart grids that dynamically balance supply and demand. All of these are underpinned by robust communications utilities.
So it's all network.
Exactly. These aren't just separate pipes and wires anymore. They're integrated data streams, forming a cohesive, responsive network.
And what role do green building principles play in making these interconnected utilities even smarter and more sustainable? It sounds like there's a huge overlap there.
Oh, green building practices are not just integral, they are fundamental to this vision. For example, careful attention to stormwater management is crucial.
How so?
Well, in traditional urban development, pervious landscapes, surfaces water can soak through, are replaced with impervious materials like concrete. This leads to runoff and flooding. Smart cities and green buildings designed for systems that protect ecosystems and manage water on site, perhaps through permeable pavements or green roofs, reducing the burden on municipal storm drainage.
I see.
Smart grids, which fall under the electrical utilities umbrella, can optimize energy use across the city by responding to demand and supply in real time, integrating renewable sources like solar and wind more effectively.
Right.
We're also seeing increased environmental monitoring through sophisticated sensor networks that track things like air quality, noise pollution, and even waste levels, all of which further feed into these intelligent utility systems.
So it's a constant feedback loop.
Exactly. The goal is to make these essential services not just functional, but highly efficient, resilient, and environmentally responsible, ensuring a healthier urban environment for everyone.
This sounds like a fundamentally new way of approaching urban development, moving beyond just the finished product to transforming the entire process, especially construction. How does the smart aspect revolutionize how we build cities themselves?
It dramatically shifts the entire construction process, moving from traditional, often fragmented methods to highly integrated, data-driven approaches. A prime example, and a cornerstone of modern smart construction, is building information modeling, or BIM.
Now, many people might be familiar with CAD, computer-aided design, which has been around for decades. How is BIM truly different from traditional CAD? What makes it intelligent?
That's a crucial distinction, and it's where the smart really comes in. Traditional CAD is essentially just a 3D representation of a 2D design. It's like a highly detailed digital drawing. It isn't intelligent. It can't automatically detect errors, understand material properties, or, correct information across the model if you change something in one view.
Right, it's static.
Exactly. BIM, on the other hand, is an intelligent system where every object, a wall, a window, a beam, a ventilation duct, is defined once for multiple purposes. If you change the size of a window in BIM, that change is instantly reflected in the floor plans, elevations, material schedules, and even energy analysis.
Oh, okay.
This allows for constant refinements of performance and material properties, which can then be used for complex analyses, simulation, cost estimation, and other uses throughout the entire project lifecycle, from initial concept all the way to demolition. It's a living, breathing digital model of the building.
So it's not just a drawing, it's a living database of the building. And this depth of information must have huge implications for things like energy efficiency, a critical aspect of smart cities.
Absolutely. It's transformative for energy efficiency. BIM integrates seamlessly with powerful energy analysis plugins that simulate building performance. For instance, software like IESVE, that's Integrated Environmental Solutions Virtual Environment, essentially creates a digital twin of a building.
A digital twin.
Yeah, allowing architects to quickly run sophisticated energy performance analyses. They can test everything from heating and cooling efficiency in various thermal zones to the impact of solar gain through different windows, and even calculate water and carbon usage.
Wow.
Similarly, OpenStudio provides an intuitive interface to Energy Plus, which is a powerful open-source building energy simulation program used globally for incredibly detailed performance modeling. These tools let designers optimize a building's energy footprint from the very first sketch, a critical step in smart construction, saving significant energy and money over the building's lifespan.
This level of integration, not just of data, but of different disciplines, must also require a fundamentally different approach to how projects are managed and how all the various teams collaborate.
It profoundly does. BIM is essential in enabling the close collaboration needed in integrated project delivery, IPD projects.
IPD, Integrated Project Delivery.
Yes. IPD is a project delivery method that brings all key stakeholders, owner, architect, contractors, engineers together from the earliest stages, sharing risks and rewards.
Ah, so everyone's in the same boat.
Pretty much. This fosters a lean pull flow control for detailing of MEP systems. That's mechanical, electrical, and plumbing meaning components are fabricated only when needed, reducing waste and increasing efficiency.
Okay.
It also enables a high degree of off-site pre-assembly, where large sections of the building are constructed in a factory setting under controlled conditions, then shipped to the site for rapid installation.
Prefabrication, basically.
Exactly, but highly sophisticated prefabrication. For example, the construction of the Crucell bridge structure in Finland, a complex cable-stayed bridge, demonstrated how prefabrication, meticulously planned and executed with BIM and IPD, can be almost entirely error-free. It drastically reduces on-site errors, improves safety, and accelerates construction timelines.
That's a huge shift from the traditional, often siloed construction process, where teams might not communicate effectively until problems arise. And this idea of continuous improvement sounds key here to keep refining and optimizing.
It's absolutely vital, and it's embedded in the DNA of smart construction. The PDCA, or Plan-Do-Check Act, process is a cornerstone of continuous improvement, effectively a process for learning from experiments.
Plan-Do-Check Act.
Yep. Applied rigorously in project management, it means you plan an intervention, implement it, that's the do, check its results against expectations, the check, and then act to standardize the improvement or refine the plan, the act.
Got it.
This continuous feedback loop is critical for optimizing both construction processes and, by extension, the ongoing development and management of smart cities, allowing for iterative improvements, adapting to new data, and constantly striving for better outcomes.
And what about sustainable building practices? How are these specifically integrated and measured in this smart construction paradigm beyond just energy simulation?
Well, this is where the long-term vision for livable cities really comes in. It's not just about efficiency, but about enduring environmental responsibility. We've seen incredible progress. Energy consumption standards for new U.S. buildings, for instance, have been reduced by more than 50% since 1998.
That's huge.
It is a massive achievement driven by smart design and technology. However, new challenges constantly emerge, focusing on influencing additional energy reductions in areas like integrating natural systems, optimizing urban planning for microclimates, and enhancing overall environmental quality.
So the goalposts keep moving, pushing for even greater efficiency and sustainability. What specific design elements and strategies are being used today to achieve these ambitious targets?
Our sources detail several, often highly integrated design elements. These include daylight-optimized building footprints, which means designing the building's shape and orientation to maximize natural light penetration, reducing the need for artificial lighting.
Makes sense.
We also see climate-responsive window-to-wall area ratios, where the amount and type of glazing are carefully chosen based on the local climate to manage heat gain and loss. High-performance glazing itself, with multiple panes and specialized coatings, dramatically improves insulation.
Right.
Then there are solar shading devices, like external fins or louvers, which actively block unwanted solar heat gain in summer while allowing winter sun. And crucially, daylight-responsive electric lighting controls automatically dim or turn off artificial lights when sufficient natural light is available.
It's a holistic approach.
It is. For instance, German regulations stipulate that occupants in an office building must be within 15 meters of an outside window, ensuring both daylighting and views. That's a very human-centric approach to energy efficiency, acknowledging the psychological benefits of natural light.
It sounds like there's a strong economic incentive, too, beyond just the environmental benefits for investing in these high-performance green buildings. Are we seeing a clear return on investment?
Absolutely. High-performance green buildings offer demonstrably strong economic benefits in diverse categories.
Yeah.
These aren't just theoretical, they're quantified. We're talking about savings in energy, water, and wastewater, reduced operations and maintenance, O&M costs due to more efficient systems, and improved maintainability.
Okay.
Beyond that, there are substantial benefits to health and productivity for occupants and reduced emissions. Quantifying these often requires complex analysis using the simulation tools we just discussed.
Right.
And yes, there's a clear market premium. We even have data showing the cost premiums for lead and C certification. For example, a platinum certified building might command a 6.50% premium. This shows that the investment in smart, sustainable construction is increasingly seen as not just environmentally responsible, but a sound financial decision that drives market value.
So we've painted this incredibly detailed picture of efficiency, of astounding technological potential reshaping our cities, from how we move and use utilities to the very way we build our urban fabric. But here's where it gets really interesting, and where we move into the complexities of the human element. This technological leap also comes with a significant shadow side. Let's talk about the profound challenges and ethical questions that these smart cities inevitably raise.
This is truly the critical dilemma we must confront. The core mechanism of smart cities, as we discussed right at the top, is that vast ecosystem of sensors, relentlessly collecting information from every inch of urban space.
Yeah, that constant data stream.
Exactly. Well, this constant data stream enables all that incredible efficiency. It immediately and fundamentally opens the door to profound questions about mass surveillance and data privacy. Every sensor becomes a potential eye. Every piece of data, a potential record of our movements, our habits, our very lives in the public realm.
And that leads directly to one of the most contentious questions. Who owns all this data? If the city is essentially a giant sensor, and individuals are constantly generating data just by existing and moving within it, who ultimately controls that incredibly valuable and sensitive information?
That's the implicit question that absolutely needs to be made explicit because it has massive societal implications. We're in an era where multinational corporations play an enormous, often unchecked role in our digital lives.
For sure.
Peter Drucker acutely pointed to the divorce of economy and sovereignty, meaning there's a genuine world economy that increasingly determines developments and shapes our technological landscape, but sovereignty is still exclusively national.
So a mismatch.
A huge mismatch.
Yeah.
This creates a massive power imbalance. The vast amounts of data collected from the public realm could be owned and controlled by private entities, by powerful corporations whose primary allegiance is to their shareholders, not to the citizens of a particular city. These entities are often not bound by local democratic processes or national laws in the same way a city government might be, creating significant challenges for accountability and citizen rights.
This really does sound like the unthinking monster that some critics warn about. The idea that technology, left unchecked or without sufficient ethical guardrails, could become something beyond our control, shaping society in unforeseen and undesirable ways.
Indeed. Anti-technologists like Samuel Florman have long warned of undisciplined technology and the profound risk of a technological takeover. They express concerns that technology will dictate to man, potentially becoming an unthinking monster that, in its relentless pursuit of efficiency, reshapes our lives, our public spaces, and even our social interactions in ways we didn't explicitly intend or approve of.
Yeah.
These are not abstract fears. They are direct, looming consequences of poorly managed, ubiquitous data collection and unchecked corporate control in the smart city. The efficiency it provides could come at the cost of genuine human autonomy.
And it's not just about control, it's about the very soul and vibrancy of the city, isn't it? The profound risk that in our pursuit of ultimate efficiency and technological perfection, we could inadvertently create cities that are sterile, losing that vibrant, messy, unpredictable human element that makes urban life so rich and appealing.
That's a truly profound concern, and one that echoes historical urban planning debates. Jane Jacobs, for instance, offered a powerful and enduring critique of top-down rationalistic planning.
Jane Jacobs, yes.
A legend, absolutely. She specifically targeted the utopian, almost clinical vision of modernists like Le Corbusier, who famously envisioned a city as a wonderful mechanical toy, a city of isolated towers, segregated functions, and grand empty spaces.
Right, the radiant city idea?
Exactly. Jacobs argued that his approach, which often involved cutting streets, creating vast superblocks, and literally keeping pedestrians off them, produced a dazzling clarity, simplicity, and harmony that shouts, "Look what I made," but ultimately tells nothing but lies about how a city truly works and how people actually live in it.
So it might have looked beautiful and orderly on paper or from a helicopter view, but it fundamentally failed at the street level where real human life, with all its spontaneity and complexity, actually happened. It stripped away the very elements that fostered community.
Precisely. Jacobs emphasized the invaluable, almost magical qualities of lively sidewalks and a functional order that demands intensity and diversity. She argued that a truly successful city street needs a mix of uses, eyes on the street, and short blocks to encourage walking and spontaneous interactions.
The ballet of the sidewalk.
That's the one. It's not about an impression of endlessness or abstract beauty, but about complex, interwoven human activities. This highlights the crucial risk of creating cities that are efficient but also sterile and overly controlled. Cities that might perform flawlessly by data metrics, but lack the messy, humanistic qualities that foster belonging, serendipity, and genuine urban culture.
This tension between pure rational form and the lived human experience echoes a long-standing debate in architectural philosophy, doesn't it? The struggle between structure and ornament, efficiency and soul.
It absolutely does, and it's a debate that informs our understanding of the smart city's aesthetic. Viollet-le-Duc, the great French architect and theorist, for example, distinguished between Greek architecture as an unclothed body, where the structure itself dictates the forms, honest and pure, and Roman architecture as a closed body, where decoration sometimes feels applied, foreign to the underlying structure. Medieval French architecture, like Greek, he argued, integrated decoration with the structure itself.
Interesting distinction.
It raises a vital question for our smart cities. Are they an unclothed body of essential, efficient function, beautifully revealing their technological skeleton, or a clothed body of technological adornment, where the smart elements are simply overlaid onto existing problems, perhaps masking a lack of genuine human purpose or intrinsic beauty?
And that ties directly into Frank Lloyd Wright's perspective, who is certainly a champion of organic, human-centered design, critical of superficiality.
Precisely. Wright believed that good architecture is an embodiment of truth, beauty, and a response to the environment and human needs. He was vehemently critical of superficiality and mere decorative forms that lacked a deeper connection to purpose or place.
Right.
This reinforces the idea that design in a smart city should serve humanity, connecting deeply to the environment, not just be technologically impressive for its own sake. Similarly, figures like Adolf Loos with his provocative statement, "Ornament is crime," and Hendrik Petrus Berlage, who called for the wall to be shown naked in all its sleek beauty, underscore a historical architectural aversion to unnecessary embellishment. This resonates powerfully with the fear of sterile, overly controlled smart cities where technology might become an ornament rather than an integrated, purpose-driven element.
These philosophical arguments gain even more weight when we consider the often brutal realities of large-scale urban development and the powerful individuals and systems that frequently drive them. This isn't just about elegant theories, it's about real power dynamics that shape millions of lives.
Indeed. Robert Moses serves as a stark, indelible historical example of a power broker who profoundly shaped cities, particularly New York, through immense public works like expressways, bridges, and parking garages.
The ultimate power broker.
He really was. He was a master at using practical politics only to further his dreams, accumulating vast, almost dictatorial power by controlling permits, bonds, and commissions. His cooperation famously stopped the moment it interfered with his grand vision.
Right.
He bulldozed neighborhoods, displaced communities, and prioritized the automobile over public transit and pedestrian life. This illustrates the centralized, often undemocratic power dynamics that can drive urban development and raises critical questions about democratic oversight in large-scale, smart city projects where a single powerful vision, even if well-intentioned, might overwhelm community needs and local voices.
It's almost like a single-minded pursuit of a goal, which can be incredibly effective at times, but also deeply problematic if it ignores human-scale impacts and complex social systems. And then there are systemic failures to consider even when the intentions are good.
Exactly. Systems thinking, as articulated by Donella Meadows, highlights how physical growing systems inevitably run into limits to growth.
Yeah.
Resources are finite, and infinite expansion is, well, a fantasy.
Right.
She also introduced the concept of bounded rationality, which is crucial here. It's the idea that economic and political actors don't always have perfect optimality on complete information. They don't know everything or can't process it perfectly.
Okay.
This partial information, combined with complex interdependencies, can lead to disaster through phenomena like policy resistance. Think of it like trying to squeeze a balloon. You fix one bulge and another pops up elsewhere because the underlying system wasn't fully understood.
Unintended consequences.
Precisely. A smart traffic system designed to reduce congestion on a main artery might, unintentionally, push more cars onto residential streets, creating a new problem for those neighborhoods. Applying this to smart cities, a singular focus on technology without understanding these systemic limits, human behaviors, and complex interactions could backfire significantly, creating more problems than it solves.
This sounds like a cautionary tale that history has already given us many times, especially when new technologies are rolled out too quickly without thorough testing or understanding their full societal impact.
It absolutely does. Consider the early days of steamboat transport in the 19th century. The sources recount a litany of failures born from technological hubris. Inferior quality materials were often used. There were significant design flaws like unrecognized weakening from rivet holes or different expansion coefficients in metals causing structural stress.
Wow.
But it wasn't just technical issues. Human factors played a huge role. Intense competition for prestige meant captains would push their engines to the limit, even tying down safety valves to build up more steam, leading to frequent and catastrophic boiler explosions, causing immense loss of life.
Tying down safety valves. Unbelievable.
It serves as a powerful cautionary tale for rushing smart city technology without robust testing, comprehensive safety protocols, and crucially, ethical considerations for human behavior, oversight, and the potential for unintended, dangerous consequences.
And if we're not careful, all this new technology, while promising to connect us, could inadvertently create new divisions, couldn't it? Leaving some members of the community behind or exacerbating existing inequalities.
That's a very real concern, and it leads us directly to the concept of the digital divide. While the sources don't explicitly name it, the idea is certainly inferred when we discuss the need for a strong commitment to safety by owners of infrastructure, or the challenges of a business becoming too big for its community, implying some members might be left behind.
Right.
The digital divide in the context of smart cities means that access to and the ability to benefit from these advanced urban technologies won't be evenly distributed. Some citizens might lack access to the necessary devices, high-speed internet, or the digital literacy to navigate these new systems. This can lead to exclusion from essential services, economic opportunities tied to the new digital infrastructure, or even from participating fully in a city's smart public discourse. Smart city initiatives, if not intentionally designed for equity, could easily deepen existing socioeconomic inequalities, creating a two-tiered urban experience where some are digitally empowered and others are marginalized.
So after exploring both the dazzling potential and the very real pitfalls, the critical question remains: how do we build smart cities that truly serve humanity? How do we move towards a human-centric smart city, one that elevates human experience rather than just optimizing it?
This brings us back to reclaiming the why in city design, moving beyond mere technological capability to fundamental purpose. Le Corbusier, despite some of his later critiques by Jane Jacobs, made a stark and powerful declaration early on. It is a question of building which is at the root of the social unrest of today. Architecture or revolution?
Architecture or revolution? Strong words.
Very strong. This powerfully reframes urban development not just as a technological or aesthetic challenge, but as a fundamental societal imperative, intrinsically linked to social well-being, justice, and stability. It suggests that if our built environment fails to meet human needs, it can contribute to societal breakdown. A smart city, therefore, must address these core social needs as its primary function.
That's a profound statement, elevating architecture, and by extension, urban planning, to a social imperative. It suggests that cities aren't just collections of structures, but reflections of our society's health and aspirations. And if we're talking about human-centric design, then the spirit of place and individual empowerment must be paramount.
Exactly. We need to create cities that resonate with human experience, fostering a sense of belonging, identity, and genuine empowerment. But Louis Sullivan's vision of a democratic vista offers a powerful framework for how smart cities could truly achieve this.
Sullivan's democratic vista.
Yeah, he imagined a society where the one becomes a vast complex of unique powers inspired of his free spirit and its power of beneficence. This is a vision of a city that uses its intelligence not to control, but to enable individual flourishing and collective good, where technology amplifies human potential rather than merely collecting data on its inhabitants. It's about designing for human dignity and agency within the urban fabric.
And to achieve this, it means learning deeply from the past, but not just replicating old forms. It's about understanding the core principles and adapting them.
Precisely. As Siegfried Gideon, the architectural historian, argued, city planning should allow for dynamic development without destroying what has already been built. The focus, he said, should be on understanding what did the builder want to achieve and how did he solve his problems, rather than just replicating superficial forms or imposing new technologies without thought.
Right, understanding the why.
Exactly. This is a crucial distinction for smart cities. It means understanding the underlying human needs, the social structures, and the environmental challenges that past urban forms successfully addressed, and then leveraging new technologies to meet those needs in dynamic, adaptable ways, rather than simply imposing a purely technological template onto a complex human system.
This leads us to identifying the real constraints, doesn't it? Because often in our excitement for technological solutions, we might think the constraint is technical when it's something else entirely, something much more fundamental.
That's the core insight from the theory of constraints, powerfully articulated by Eliyahu Goldratt. It highlights that the real constraints were not the machines, they were the policy.
Not the machines, the policies.
Yes. Applying this to smart cities, the greatest obstacles to achieving a truly human-centric future may not be technological limitations at all. It's rarely a lack of sensors or computing power these days. Instead, they could be measurements with policies, with procedures, cast already into behavioral patterns within city governance, entrenched planning bureaucracies, or even the way citizens are encouraged or discouraged from interacting with their urban environment. These human and organizational constraints often prove far more intractable than any technical problem.
So all the data in the world, all the real-time feeds and smart algorithms won't fix a bad policy or an outdated way of thinking?
Not on its own, no.
Yeah.
The theory clearly states that data management alone isn't going to give us more control. True control and true sustainable improvement comes from understanding these deeper systemic, often non-technological constraints, and being willing to critically examine and change the underlying policies, the incentive structures, and the entrenched practices that actually govern a city's behavior.
Yep.
It requires a deeper look into the systemic issues, not just collecting more information. Data can inform policy change, but it doesn't enact it.
And to continuously address these issues and adapt to the ever-changing needs of a city, we need a robust framework for improvement, something that's built into the very process of city development and ongoing management.
That's precisely where the PDCA, or Plan Do Check Act, cycle becomes invaluable again. It's a pragmatic, iterative process for learning from experiments, which is vital for continuous improvement in any complex system.
That feedback loop again.
Exactly. By standardizing this practice in urban development, by consciously planning interventions, implementing them, rigorously checking their actual impact against intended outcomes, and then acting to adjust or standardize, smart cities can continually refine their strategies. This ensures that technology truly serves human goals, adapts gracefully to unforeseen challenges, and avoids remaining static or inadvertently creating new problems. It's a cycle of constant, informed evolution.
So what does this all mean for the fundamental principles that should guide us in building a truly human-centric, smart city? What should be our North Star?
It means we must always return to purpose-driven design. Viollet-le-Duc noted that for Roman architects, the purpose of each building or part of a building indicated the proper dimension and form. Similarly, in the Middle Ages, the structure and purpose of a building are manifest from the very ground plan.
Form follows function, essentially.
In a deep way, yes. This ancient yet timeless principle, that design must serve a clear function and address a fundamental human need, must fundamentally guide smart city development. It ensures technology isn't just an add-on or a flashy embellishment, but deeply integrated into the urban fabric to authentically serve inhabitants' well-being, daily lives, and broader aspirations.
That makes profound sense. Cities are complex, dynamic systems, and they need to be able to evolve and adapt, not just be static technological marvels.
Exactly. Donella Meadows reminds us that for long-term success and genuine sustainability, cities need to be inherently resilient, self-organizing, and hierarchical. This adaptability is key. A smart city can't be a rigid, top-down imposition that ignores local context or changing needs.
Right.
It must be designed to withstand shocks, whether they're environmental, economic, or social, and to allow for organic, self-organizing growth and adaptation from the bottom up, while still benefiting from overarching strategic direction. This fosters its own continuous evolution, truly serving its inhabitants over generations.
And ultimately, what is the human reward in all this ambitious building and planning? Beyond efficiency and sustainability, what's the deeper, almost primal motivation that drives us to shape our urban world?
Samuel Florman, in his Reflections on Engineering, speaks of the existential pleasure of building and creation. He suggests that when engineering and building are done with profound purpose and in the face of significant challenge, they bring this deep intrinsic pleasure, often as a byproduct of the effort, rather than a direct, self-conscious pursuit of happiness.
The joy is in the striving.
Kind of, yes. He quotes Andre Gide, "Man's happiness lies not in freedom, but in his acceptance of a duty." This reminds us of the intrinsic human value in the endeavor itself, the satisfaction of grappling with complex problems, overcoming immense challenges, and creating something enduring, beautiful, and beneficial for humanity. That profound sense of duty and achievement, that joy of attaining, should be at the very heart of building our smart cities, ensuring they resonate with our deepest human aspirations.
That's a truly powerful and reflective thought to leave us with. This deep dive into the smart city has truly shown us a dual landscape, one of incredible technological promise for efficiency, sustainability, and heightened livability, but also one fraught with peril. We've seen the critical need for human oversight, robust privacy protection, and a steadfast focus on truly enhancing urban life, not just optimizing its mechanics.
The central question isn't just about how much data we can collect or how quickly we can automate processes. It's about the fundamental purpose of our urban environments. Are we simply chasing technological solutions, layering new gadgets onto old problems? Or are we fundamentally rethinking what a city is for its inhabitants? Are we designing for a truly vibrant, equitable, and human future?
Exactly. The true smartness of a city might not ultimately be found in its sensors and algorithms or in its capacity for mass data collection. Rather, it might be found in its ability to foster genuine human connection, empower individual agency, protect our privacy, and cultivate a deep sense of belonging within a truly livable, equitable, and democratic public realm.
Well said.
So, as you go about your day, moving through your own city, think about this. What does a smart city truly mean for your daily life beyond the raw data? What responsibilities do citizens and planners alike share in shaping this incredibly complex and rapidly approaching urban future?